Okay, so today for science, we are going to continue with our study of weather prediction. So go ahead and log into TCI via Clever and go ahead and get into the class. And then we are going to choose weather and climate. Click on the words. And then scroll down a bit until you get to lesson 5, how is weather predicted? And then we're going to dance to the purple bar and choose text with notes. Okay, and then today we're doing section 2, so make sure in the section bar you choose the triangle and click on section 2, describing air masses and fronts. Okay, so like yesterday, you can either decide to stay in TCI and just follow along with me while I read. I will be doing it in Notability so I can annotate. However, you will be returning to TCI to do the check for understanding activity here, and you'll be posting these maps onto Seesaw. So eventually you will return to TCI. Whether you want to dance with me to Notability, you can, or you can just stay at TCI. So I'm going to buzz over to Notability. All right, so I have to tell you what I just did. I recorded this without the microphone on. So as you can see, I have all these notes already because I just did all this. So here we go. I will just reread and go through this. So we are going to be talking about describing air masses and fronts. So we're in section 2. Air masses and fronts are words I'm wondering about. They sound familiar to me, especially fronts, because I do recall when we were watching the WGN daily weather forecast a few weeks ago. I guess it's more like a month ago. I remember them talking about the fronts. So here we go. You learned that air is always moving. So always moving, I recall that it's always moving west to east. Knowing how air moves can help predict the weather. So here we have our first heading, which is air masses. So hopefully this is going to answer my question, what air mass is. Imagine a giant bubble of air floating above several states. If you could move around inside it, you would find that the air temperature is about the same wherever you go. So is the humidity. Air in the atmosphere is like this. A large body of air of the same temperature and humidity is an air mass. So there's my definition right there. That a large body of air of the same temperature and humidity is an air mass. So that's my definition. I also noticed that the words temperature, humidity, and atmosphere are already words that we have talked about in prior science lessons that are probably in your book creator weather books. So you might want to be adding air mass to your book creator and using this definition. Air masses are described by where they form. Air masses that form over a cold ocean are cold and humid. Air masses that form over a hot desert are hot and dry. Knowing about air masses helps people predict the weather. Suppose an air mass forms over a warm ocean and moves over North America. It would bring warm, humid weather with it. So my 1 and 2 over here, I found 2 examples that they gave to me about air masses. So one example is that it could form over a cold ocean and it would be cold and humid, or air masses that form over a hot desert are hot and dry. There's my second example. So I did find a cause and effect as well. So if an air mass forms over a warm ocean and moves over North America, it would bring a warm, humid weather with it. So here's another picture, a graphic that could help you with understanding, and also something you might want to take a screenshot of and put in your book creator. An air mass can form over a warm ocean and move on to land. The air mass would bring warm, humid weather with it. All right, so here's our second topic of this section, fronts. So you may have heard someone say, a front is coming in. That usually means the weather is about to change. So that equals or front, or that is what a front is. When one air mass meets another, they do not mix right away. They push against each other. The line where two air masses meet is called a front. Fronts often bring weather changes. They are shown on weather maps as blue or red lines. Knowing about fronts can help people predict weather. So again, here's my definition, that the line where two air masses meet is called a front. Right here is my definition. So here's kind of a key detail, that the fronts often bring weather changes. So as I'm reading this and I'm thinking red or blue lines, that's kind of ringing a bell for me when we were watching that WGN weather forecast. And Cole Nelson, I can just hear you saying right now, idiom, because ring my bell is an idiom. You're absolutely right. Or ringing a bell. Side note. Okay, so back to this. For example, a cold front is the edge of a cold air mass that is moving into a mass of warmer air. When a cold front meets a warm air mass, cold air moves underneath the warm air. Clouds and thunderstorms can form along the front. As the front passes, the wind changes direction. Once the new air mass is overhead, the skies may clear again, but temperatures are cooler now. So I made my little arrow here because I felt like this paragraph had quite a bit of information and that I definitely had to go back and read it again because this was a little bit confusing to me. So I kind of drew a diagram here to kind of help my thoughts. So cold air is moving into the warmer air. So here we've got the cold air moving into the warmer air. The cold air will meet the warm front, and then that cold air moves under the warm air. The clouds are forming, and thunderstorms can form along the front as well. I guess this is technically more lightning than thunder, but here's my thunder. Boom. As the front passes, the wind changes direction. Once the new air mass is overhead, the skies may clear again, but temperatures are cooler now. So again, I kind of found a cause and effect example as we were reading. And then, because my picture is not spectacular, of course, they have a much better picture that you would probably use for your book creator if you were still inclined to do that. For my people who like to go the extra mile, you could put this in for fronts. As you can see, it says cold front there. So where two air masses meet, a front forms. Clouds and storms often form along a cold front. These would kind of be my two big takeaways here from this section. Okay, so that is what we read today in the text. So now you're going to need to go back to TCI, and you are going to complete these maps. For each map, they're asking that you draw either a cold front or a warm front and where it needs to stretch from. I can't write on TCI, but if you recall in our reading, it said a cold front is usually represented by blue and a warm front is usually represented by red. You have two options here because you guys are experts. You are certainly able to complete the activity right here in TCI using these tools. However, if you are more comfortable using Seesaw, you could go ahead and screenshot each of these maps, post it into Seesaw as a new post, and then you could use the Seesaw tools to complete the activity if you're more comfortable using those tools for the colors and such to make your warm front or cold front. Either way, you have to complete these 4 maps. Number 2 is drawing a warm front. Number 3 is drawing a cold front. And number 4 is drawing a warm front. It's your decision. But either way, at the end of your day today, in order for you to have completed science, I need to see 4 maps. with either a warm front or a cold front on each one posted in Seesaw. I did post on the slideshow today that you're working off of, hopefully, the link to the WGN daily weather forecast, the ones we were watching in class. And maybe if you watch that, you can get some ideas or a visual about how those warm fronts and cold fronts can be drawn. So I look forward to seeing your warm fronts and cold fronts, and thanks for listening.